Hi there. In this video, we're going to be adding and subtracting fractions. Again, this should be a review for most of you, but it's important to remember. The only difference this year is that now that we know about positive and negative fractions, we're going to be including positive and negative fractions when we add and subtract. So just pay attention to those. All right, the first type of adding problem you might have is when the denominators are already alike, or they already have a common denominator. When that happens, you just add their numerators. Remember, numerators is the top part of your fraction, and you're going to keep the denominator. It's not going to change. Remember that denominator is the bottom part of your fraction. The last step with any fraction problem is to simplify, so be sure you're double checking your answer at the end to see that it's simplified. All right, so here's the first type of problem. You can see that the 9 is the same denominator for both of these. That means I can go ahead and add their numerators. So just add 5 plus 1. That gives me 6, and I keep the 9. Last step is to simplify. These are both divisible by 3. So 6 divided by 3 is 2, 9 divided by 3 is 3, and then that's as low as I can simplify this fraction, so it's going to stay 2/3. In the second problem, you can look and see that their denominators are both 5. This negative is in front of their fraction, but we can think of it, we can kind of, we're allowed to move this negative wherever we want it. So we're going to move it up to the 3 and think of it as a negative 3 over 5 plus 1 over 5. And when that happens, we just keep the 5 the same, and then we're just thinking to ourselves, okay, what is negative 3 plus 1? This is where you have to know your rules for adding integers, and because their signs are different, we actually subtract the numbers. So 3 minus 1 is 2, and we keep the sign of the most. So there are more negatives, so this is negative 2, and then that doesn't change the 5. It's still just a 5. So this becomes negative 2/5 as our final answer. So again, all we did was keep the same denominator. We add it, we move the negative to the 3, and then add it negative 3 plus 1 to get negative 2 over 5. All right, if you're subtracting fractions, basically it's going to be the same process when their denominators are the same. The only extra step you want to take when you're working with positive and negative numbers is to rewrite the problem first as addition. It's just easier and simpler that way. And we've talked about different ways you can do that. Add a line, change the sign. Some of you may have learned keep, change, opposite. Some of you learned copy, change, opposite. There's lots of little sayings you can use to help you remember that. Just whatever you use. I use copy, change, opposite here. Don't forget when you're working with like a negative number that you want to do that first. After you've done that, then the steps that follow are just the same as we used before. You're going to add the numerators, keep the denominator, and then simplify. So in this problem, because we have a negative 5/8 minus 3/8, the first thing I'm going to do is rewrite the problem as addition. So if I copy the negative 5/8, I'm going to go ahead at this time and move the negative up to the 5. And then I'm going to change the subtraction to addition, and I'm going to use the opposite of 3/8, which is negative 3/8. Okay? Or if you're thinking of adding a line, changing the sign, that works as well. They have the same denominator, so now you're just thinking to yourself, what is negative 5 plus negative 3? So the rules when you add numbers that have the same sign is that they keep the same sign and you just add them. So negative 5 plus negative 3 is negative 8. Keep the denominator, and then I simplify. Now 8 over 8 simplifies to just 1 whole, and because it's negative, it's just negative 1. All right, on bottom, I'm going to do the same as I did before. I'm going to rewrite the problem using copy, change, opposite, or add a line, change the sign. So I'm going to copy the negative 11/12, moving the negative up with the 11. I'm going to change subtraction to addition. I'm going to use the opposite of negative 5/12, which is positive 5/12. I don't need the positive sign. I just can write it without the negative. All right, the denominators are the same, so I just need to know what is negative 11 plus 5. When the signs are different, you subtract. 11 minus 5 is 6. Keep the sign of the most. We have more negatives, so this is negative 6. We don't do anything to our denominator. It stays the same as 12. I want to make sure I'm simplifying. So these are both divisible by 6. This becomes negative 1 over 2, or negative 1/2. Okay? All right. Let's look at the second type of problem, and that's when you don't have like denominators or a common denominator. So again, that's going to require an extra step. I'm going to rewrite the fraction using the least common denominator. First, you have to find that common denominator. You may have called this the least common multiple, right? They're basically just the same thing. Step 2 is to add as you did before, and then simplify. So in this problem, 1/6 plus 2/3, I can see their denominators are different, so I need their least common multiple. So if you've forgotten how to find that, one way is just to list the multiples. I know the multiples of 6 are 6, 12, 18. Multiples of 3 are 3, 6, and then I can stop when I get a multiple that's the same. These both have 6 in common, so their least common multiple is 6. This fraction, this first fraction, 1/6, already has the 6, so it's not going to need to change. It's going to stay 1/6. This 3, though, needs to change to a 6. In order to do that, what do I have to multiply by? 3 times 2 is 6, so I need to multiply this by 2. Whatever you do to the bottom part of the fraction, you must do to the top. So if I multiply this by 2, I need to multiply the 2 by 2 as well. So now I'm going to add, instead of 2/3, I'm going to add 4. 2 times 2 is 4, and 3 times 2 is 6. And I'm back to what I did before. Add the top numbers. 1 plus 4 is 5. Keep the denominator 6. And then this will not be simplified. That's my answer. Number 2, the denominators are 5 and 4. So my first step is to find a common denominator. I need to know their common multiple. I can start by listing the multiples of 5. 5, 10, 15, 20. The multiples of 4 are 4, 8, 12, 16, 20. I can see they have 20 in common. So this time both numbers are going to have to change. What do I multiply by 5 in order to make it 20? I multiply by 4. Again, I'm going to do the same thing on top. Over here, to change the 4 to a 20, I have to multiply it by 5. So again, I do that on top. Don't lose the negative, though. 3 times 4 is 12. I keep that negative, though, although I'm going to move it with the 12 and make it negative 12. 5 times 4 is 20. Keep the addition sign. And then over here, 1 times 5 is 5, but the negative is going to come with it. And then 4 times 5 is 20. Now, I'm kind of ignoring the denominators and just answering this question. What is negative 12 plus negative 5? Well, if the signs are the same, they're both negative, I add 12 plus 5 is 17, and I keep the sign, I keep the negative. Then the denominator will not change, it's still a 20. Last step, can you simplify it? Not in this case, this is negative 17/20. Let's look at subtraction. First thing, always with subtraction, when you have negative numbers involved, you want to rewrite it as addition first. Okay, you can use copy, change opposite, add a line, change a sign, whatever works for you. Then rewrite the fraction using the least common denominator. Add as you did with like fractions, or subtract as you did with like fractions, depending on what you need to do. That probably should say subtract. I will change that on yours. All right, and then step 4 is simplify. All right, so again, 8 and 4, not the same. I need to make them the same. The multiples of 8 are 8, 16. The multiples of 4 are 4, and then 8. 8 is our common denominator. This one does not need to change. This one I can change by multiplying by 2. And I skipped the first step on this one since it just looked to me like a regular subtraction problem. I'm not gonna rewrite it. Now I could rewrite it and still get the same answer, but this one might be simple enough to just leave it. So I'm gonna try it, at least start out this way. So 5/8 minus, and this becomes 2/8. All right, so subtract 5 minus 2, I can do that. So that would be 3. Keep the denominator in 8, 3/8. On number 2, negative 2/3 minus 1/2. Now this one, it's obvious that I'm working with a negative number here, so my first step is to copy, change opposite, or add a line, change the sign. So I'm going to rewrite this, then I'm going to move up the negative. Negative 2/3, keep that, change to what? Change to add, and then change to the opposite. The opposite of 1/2 is negative 1/2, and I'm going to write that negative with the 1. All right, I need a common denominator of 3 and 2. 3, 6, and 9 are multiples of 3. 2, 4, and 6 are multiples of 2. I can see that 6 is a common denominator. 3 times 2 is 6, so I need to multiply by 2 on the first one. 2 times 3 is 6, I need to multiply by 3. My new problem, and go ahead and write out all these steps so that you don't miss anything. It's really easy, especially when you're working with negatives, to lose a negative if you're not careful in writing everything out. So negative 2 times 2 is negative 4 over 6. This is now plus negative 1 times 3 is negative 3 over 6. Okay, and then I can kind of just pretend that these are not fractions and ask myself, what's negative 4 plus negative 3? If they have the same sign, I add them and I keep it. So negative 4 plus negative 3 is negative 7. The denominator doesn't change, it's a 6. Now, I don't necessarily need to simplify this, but it's not a proper fraction, which means I need to use Tybo in order to make it a mixed number. So top in, bottom out. The negative, I'm just going to make part of my answer. I can go ahead and even write it down so I don't forget it. But I'm going to do the mixed number part just without the negative. So top in, 6 will go into 7. It'll go 1 time, subtract, and get 1. So 1 is my whole number. It's negative because of the negative here. 1 was my remainder. It's my new numerator. And then my denominator doesn't change. It's still 6. My final answer as a mixed number is negative 1 and 1/6. The third type of problem you're going to see with adding fractions is when you have a mixed number. All right, so when that happens, there's, again, one extra step. You want to rewrite first the problem using improper fractions. And that you're going to do using Around the World or Texas. And if you've forgotten how to do that, there's a video about this you can go back and watch. Same thing, if you've forgotten how to change an improper fraction to a mixed number, there's a video about that. Go back and watch it until you understand how to do it. After you change your mixed numbers into improper fractions, you're going to find that least common denominator again. You're going to add like you did before and then simplify. All right, so here's an example of a mixed number. That's when you have a whole number with a fraction. Around the world, it's just the direction you're going. You're multiplying first and then adding. 5 times 5 is 25 plus 1 is 26. So this becomes 26 over 5. Over here, 2 times 10 is 20. Add the 3 is 23 over 10. Find a common denominator. So the multiples of 5 are 5 and then 10. That's the same as this one, so I can stop. That means I only need to change the 5. 5 times 2 is 10, so I need to multiply by 2. 26 times 2, if you don't know what that is, on a piece of scratch paper, off to the side, multiply it. 2 times 6 is 12, carry your 1. 2 times 2 is 4, plus 1 is 5. So this becomes 52 over 10 plus 23 over 10. I'm ready to add the numerators. 52 plus 23 is 75. My denominator doesn't change. This is, we've added it, but we still need to find a simplified answer, and it's also improper, so we also need to change it to a mixed number. So I'm going to divide top in, bottom out. 10 will go into 75 7 times. I have a remainder of 5. So again, 7 is my whole number. The remainder is my numerator, but the denominator doesn't change. 7 and 5/10. You think you're done, except that 5/10 can be simplified. These are both divisible by 5. So find the simplest version of that fraction. So this becomes 7 and 1/2 as an answer. 7 and 1/2. Okay, same steps for number 2. Start by making them improper. 9 times 1 is 9 plus 5 is 14 over 9 over here. 6 times 4 is 24 plus 1 is 25 over 6. Now, some of you may have not used improper fractions when you add it in elementary school with mixed numbers. So there's always, usually in math, more than one way to do a problem. And if you truly understand how to do it by finding a common denominator, I'm not going to tell you you can't do it that way. I will tell you to be very careful, especially with positive and negative numbers. It is often safer to go ahead and change it to an improper fraction first. All right. 9 and 6, we need to find a common multiple. The multiples of 9 are 9, 18. Multiples of 6 are 6, 12, 18. And again, I would keep on finding multiples until I found one that they have the same. Fortunately, I'm not having to go very far. They have a common multiple of 18. So this time both numbers will change. Multiply by 2 to the first fraction. 6 times 3 is 18, so 25 times 3 here. 14 times 2 is 28. 9 times 2 is 18. 25 times 3, think of quarters. 3/4, 75 cents over 18. And then I add 28 plus 75, 13, carry your 1. 7 plus 2 is 9, plus 1 is 10. So 103 over 18. This needs to be changed into a mixed number. 18 goes in, 18 comes out, 103 goes in. When you're dividing, it's often easy to, or easier to sort of estimate. I can round 18, or it's about 20, so I'm going to kind of use 20 as a way to figure out how many times 18 will go into 103. I know 20 will go into 100 5 times. So I'm thinking 18 will go into 103 about 5 times. At least that's a place to start. So one way to do that is to put the 5 here and then multiply. What's 5 times 8? 40. And then I'd carry that 4. 5 times 1 is 5 plus 4 is 9. So I'm going to subtract 90. Be careful with your borrowing. 10 minus 9 is 1. So my final answer here is the whole number is 5. 13 was my remainder. It's my new numerator. My 18 hasn't changed. So 5 and 13, 18th. Final answer. Now over here, I kind of did a shortcut for multiplying. If you don't like that, you can always, on a piece of scratch paper somewhere, just multiply 18 times 5 like you normally would. You're going to find it's 90, which is what we subtracted. All right, for subtraction, again, you just want to be really careful with positive and negative numbers. And so anytime I'm subtracting a negative number, I'm going to rewrite it first as addition. Or if I'm working at if any of the numbers in my problem are negative, I'm going to rewrite as addition first. Then I'm going to rewrite with improper fractions. I'm going to find the least common denominator. And then I'll not add, subtract. I will change this on yours. Sorry, guys. With like fractions, and then simplify. Okay, so this looks like a regular subtraction problem to me. This is not a negative. This 3 is going to be more than 1. So I'm going to skip that step because I don't think I need it for this one. So I'm going to skip to rewriting with an improper fraction. So I need to do around the world, or Texas. 8 times 3 is 24. 24 plus 7 is 31 over 8. Do the same thing here. 4 times 1 is 4, plus 3 is 7. This is 7 over 4. I'm still subtracting. All right, I need a common denominator for 8 and 4. The multiples of 8, 16. Multiples of 4, 4, 8. So I can stop, 8. This is the only one that needs to change. I need to multiply by 2. So this becomes 31 eighths minus 14 eighths. Now I just need to subtract. 31 minus 14 is going to be 17. So now I have 17 over 8, which still has to be changed into a mixed number. So divide 8 into 17. It'll go 2 times with a remainder of 1. So my whole number is 2. 1 is my numerator, and then my denominator is still 8. So this is 2 and 1/8. Okay, on number 2, again, I can rewrite this as an addition problem, and maybe I will on this one just to practice that. One way to do that is to add a line, change a sign. So I keep the first number the same. I change to add, and I change to what? To the opposite, or right here, to -2 1/2. So how would that work for this? 3 times 8, I still change to an improper fraction. That's what I'm doing here, so I'm multiplying. 3 times 8 is 24, and then adding the 2 gives me 26 over 3. Over here, I'm going to do 2 times 2 is 4. Add the 1 is 5 over 2. It's just, instead of a positive 5, because of this negative here, it just makes my 5 negative. And then the adding, I've changed it to add, so now I'm looking at this. I need a common denominator of 3 and 2, so the multiples of 3 are 3 and 6. The multiples of 2 are 2, 4, 6. Hopefully you can start to do some of this in your head. If not, you can always list those multiples. So 6 is a common multiple. I need to multiply by 2 on the first fraction, multiply by 3 on the second one. This becomes 26 times 2. Again, if you need scratch paper to multiply that, do it. But I know that 26 times 2 is 52 over 6. 5 times 3 is 15, so this becomes a negative 15 over 6. And so I'm ready to add. Because I'm adding unlike numbers, one is positive, one is negative, I actually end up subtracting these. 12 minus 5 is 7, 4 minus 1 is 3. So I've subtracted, and then I keep what I have more of, the sign of what I have the most. So I have more positives, so this is positive 37 over 6. This is still not correctly written. I need to typo. So top in, 6 will go into 37 6 times. I have a remainder of 1. So my final answer, 6 is my whole number. 1 is my numerator. And then my denominator is still 6. So 6 and 1, 6. 1, 6 looks good. I don't need to simplify it. Last problem. This one looks a little different because you're subtracting a whole number and a mixed number. Your steps stay the same. I still need to rewrite this as an improper fraction. Now again, I could rewrite as addition, and definitely I would if this were a negative 7 or if this was minus a negative 4. But because it looks like just a regular subtraction problem, I'm probably going to be okay if I leave it as subtraction. So I'm going to skip that step. Again, it won't change your answer if you do rewrite it. So if you prefer to do that, go ahead. 7, to make 7 an improper fraction though, I have to remember that it has to be written over 1. Then this one is going to be 3 times 4, which is 12, plus 2 is 14 over 3. I need a common denominator of 1 and 3. So when, in this case, the common denominator would be 3. So I need to multiply this one by 3. 7 times 3 is 21 over 3 minus 14 over 3. And then I subtract 21 minus 14 is 7 over 3. Then to change this into an improper fraction, into a mixed number, I'm going to divide 3 will go into 7 twice. Subtract 6 with a remainder of 1. So my whole number is a 2. My remainder is my numerator. My denominator isn't changing. It's 2 1/3. That's already simplified, so my final answer is 2 1/3. All right, so adding and subtracting fractions, really same steps, just keep getting repeated every time. Just be careful that you're watching out for those positive and negative signs. Once you have a common denominator, you're really just doing the numerators like a regular integer problem and just using the denominator at the end as part of your answer. Okay, that's adding and subtracting. See you soon.